here. You have some links here that these two links are everything that we'll need in order to get started. So feel free to already download the samples or spin up a Lakefest environment. We're going to wait a few minutes until we start. For those of you that joined already, thank you for being early. We'll be starting in a few minutes. In the meantime, in front of you, you have some links that we will be using throughout the demo. So if you want to follow, you can use these links. Again, for those of you who are early, thank you for joining. We'll wait just a couple of more, maybe 1 or 2 more minutes. I still see people coming up. In the meantime, you have links in front of you that we'll be using throughout this webinar for the demo. So if you want to click along, and as we demo what we're doing, feel free to download. Okay, I see some last people joining. I think we're a minute after the hour, which sometimes in the tech world means early, but nevertheless we have critical mass, so I think we can start. Hi everybody, I'm Ido. I am with Lakefest. I run customer success here. With me is Amit. Hi Amit.
Hey.
How's it going?
Good, good, excellent. Thank you.
Excellent, great. So Amit and I are here today to walk us through how to develop Spark ETL pipelines risk-free against production data without ever copying that data. Before we start, just a little bit of housekeeping for everyone's privacy. Your own names are hidden, so you don't see the people that are here. Having said that, if someone has a question, you should be able to post it on the Q&A. Keep in mind that I believe that when you post a question, you can do that anonymously or you can do that with your name. That's completely up to you. If you do it with your name, then everybody here will see your name as well. I don't know if you care, but that's how we configure this. Feel free to ask questions also anonymously as much as you want on the Q&A. So before we start, I have just one question for everybody that we're going to post here in the chat. This can actually, getting some answers here can help us on the demo that we're going to do here, just to make sure that we can use a few technologies. So whatever you answer here can help us actually present the best. So please, if you can just include your technology stack, that would be great. Okay, so without further ado, I think we will start. So we're here to talk about developing and testing Spark ETLs, and obviously developing and testing pipelines is important, and not only basic unit testing, but also integration testing, load testing, end-to-end testing against production-like data, because if you skip any of those steps, you get any one of those pictures that you see here where the unit testing actually worked, but the more end-to-end testing did not. So it's something that we do today. Everybody here, I'm sure that when you develop ETL jobs or pipelines or maintain them, we do some sort of testing in place. And I'll go ahead and ask Amit. You've been doing this for a while, I think a couple of decades, not to embarrass you, of data engineering roles. So my question to you is, let's say that you're developing a new pipeline and you need to test it today or just work on it today. How do you start? What do you typically do?
Yeah, normally let's say if I have some object store or if I have storage, I'll create my own bucket and then create a private bucket, take some sample data from production and then point my ETL job to that like private bucket or private sample data set, and then do my units testing, try to run multiple times. And once my testing is done, then I point my ETL job to production and then hope and pray. And then sometime if things go wrong, I go back and try to do the same process over and over again to make sure my ETL job, everything works fine. So it takes a lot of time and the probability of failures are pretty high in that scenario.
Yeah, I think we speak. You and I speak a lot with data engineers on a regular basis, and one of the common areas of friction, I'll say, is okay. I developed my code and now I'm going to run it in production, especially when sometimes it's retention jobs, right? The delete data. So we see one of two things: either you develop somewhere against a sample of the data, which is not good enough, or a copy of the entire production data, which is expensive, takes time, takes multiple, difficult to maintain. And then you point it to production. And basically the first time that you run your data against production is when it runs against production. Or there is something that people like to talk about, promoting data, which is basically I run my ETL somewhere and then I manually copy data to production. But that's the best that we have. That's the best that the industry gave us. As you call out, this is not safe. We often have issues, and it's very hard to operate this way. So that's where Lakefest comes into the picture, and we're going to review that a little bit today. How our approach was to manage data the same way as you manage code. Right? When I develop code, if I want to get a completely isolated environment of my code to develop against, then I will go to Git and I will create a branch and I will work on my branch. And we said, let's take this approach and put something in place that you can spin up very quickly, and Lakefest can be up and running in minutes. And then it sits on top of the object store and provides these Git-like capabilities on the object store. So branch, merge, revert, commit, and so on, all those things that we're aware of through an API. So the ecosystem of tools that we have today can either run against the object store regularly the same way that they always have, or through Lakefest and then get versioning capabilities. Meaning, from a technical point of view, we did the integration very quickly. So you spin this up very quickly, and you can integrate very quickly because we provide a gateway. So from now on, instead of accessing a collection on a bucket, we will just include a name of a branch or a commit identifier. So I can take main, I can branch from main out to test, and then instead of accessing main, I can access test, and I continue working on my pipelines and developing my pipelines the same way that I always have. And then those Git actions, such as the branching, can be done through the API or through a web interface that we will see soon, or through a command line interface, for example, a Lakes ETL command that creates a branch out of main and calling it testing Spark 3. So that's Lakefest. And when we do that, that means that if I want to develop against Spark ETLs, and we'll show you how that is done, then I can literally just take my environment, branch it, and develop in isolation against a completely isolated environment of my production environment. So there's absolutely no risk of me doing anything badly in production. And we do this with zero clone copy. So we don't actually copy any of the files. This is all metadata manipulation. And if someone has questions about that, we can go into the details about that as well. And then another thing that we're not exactly discussing in this webinar, because it's not the topic, is I can also promote data to production by merging it. So I can run my ETL, see that I'm happy, and then atomically put everything back into production. So this is a super simple operation that follows engineering best practices that we're familiar with, and is available now not only to our code, but also to our data. The next thing that we're going to do is we're going to kind of show you how this looks like using Lakefest. Before we do that, and I hand over the presentation to Amit, I would like to ask one more question, because we are going to review Lakefest today, and I do wonder how many of us have heard of Lakefest before this webinar, or is this the first time that we're actually taking a look into this? So if you can, please let us know if you ever heard of this before, or this is the first time that we're presenting this. That's gonna be helpful for us in what we're covering, how slowly we want to go over some key factors. So appreciate that. Let you guys answer on that. That's great. And Amit, I'm gonna pass it over to you, and if you can walk us through how within 2 minutes we're gonna spin up Lakefest, integrate with our environment, and develop in isolation.
Yeah, sure. Thank you. Let me share my screen.
We see it.
Okay, cool. Let me just hide some Zoom controls here. 1 second. I think I did something wrong, so let me share again. Can you see my screen now?
We see it again? Yeah.
Okay.
Thank you.
So I'm going to walk through the whole process to kind of set up the Lakefest environment and run your ETL job. In this case, I'm going to use a Spark ETL job, run in isolation to your production data. So let's go through that. So first thing, there are two prerequisites for this. One is to have Docker running on your local environment. So I'm going to run this demo on my laptop. So it requires a Docker container. So we have everything packaged in one single container for this demo. So that's where you need to run Docker. And then you need access to the Lakefest server. So you can either install Lakefest on your local laptop, or you can use Lakefest Playground, which is an online, on-demand single-click installation or single-click availability of Lakefest It's available in demo.lakefest.io. So those are two prerequisites for this demo. So let's get started. So I already have Docker running on my laptop. So let's sign up for Lakefest Playground. So let me go to that. So once you go to this URL, demo.lakefest.io, which is our playground or demo environment. So here you'll sign up and provide your email address, and then within few seconds, your playground or Lakefest server environment will be up and running, and you'll receive the credentials via email. So the email will look like something like this. So your playground is provisioned in few seconds, and then you click on this playground, and it will give you the credentials to connect to the playground. So in this case, it will tell you the URL for the playground. So let's go there. And then once you get that URL, let me log out first. So I'm already logged in, so let me log out. So here it will ask you to log in with access key and the secret key. So let's get that. So again, copy this access key and then get the secret key also. So now your playground Lakefest server environment is up and running. So let me close this thing. So here you'll see that this is running in kind of Lakefest cloud environment. And when you sign up for this playground, by default, it has one single repository. This is Lakefest UI. So by default, we create a single repo in there. You can create your own repo if you want. And also we provide, in this playground, we provide this storage bucket also. In this case, this playground is running in AWS environment, but you can run Lakefest in any cloud, whether it's a Google Cloud or Azure Cloud. In this case, we are providing this S3 bucket for testing purpose or for the playground region. But in real installation of Lakefest, you can point it to your own object store, your own S3 bucket or Azure Blob storage or Google Cloud storage, whatever you would like to use. So this is my kind of repo in predefined repo in the playground. And once you go into that, inside that repo, it has some sample data set. It has a sample notebook also. So we are going to use the notebook today for this demo too. And just quickly walk through here how this UI looks like. So you have the different branches that you have. In this case, right now, I have only one main branch. And in each branch, what different objects you have. And then you can look into your uncommitted changes, your any commits, all the history, any changes that happen in your data lake or in your production environment, or in any of the branches, you can see all the commits. And I mentioned earlier about the branches. You can create the branch from the UI, or you can create the branches from the API also. For this demo, we'll use the API, Python API client. So I'll show you that. And then,
so Amit, we had a few people that joined in the last couple of seconds. Just a follow up. So far, what we've done is we went to demo.lakefest.io and spun up a Lakefest environment on demand within minutes. And this is identical to regular Lakefest, only that this playground environment is limited in use, of course, and the data sits on our buckets. But in regular Lakefest, the data sits on your buckets, whether that's on-prem or on the cloud, on any cloud, correct?
That's correct. Yep.
Thank you.
Yeah, so it took me like a few seconds to get everything up and running. So now we have both the requirements, like prerequisite. I have Docker running. I have the playground, Lakefest playground or Lakefest environment also running. So next thing is I'm going to use a Git repo for this demo. So that repo is also available to you guys. So you can use this same repo to run this demo on your own. So let's go into that. And this is the same URL we posted in the chat. So you can go to that URL, click on that webinar sample URL. It will take you here. So this is our samples repo. in this samples repo, we have multiple notebooks. Today, we are going to use a Spark demo, but we have Delta Lake, Airflow demo. So lots of different notebooks are available, are packaged in this single repo. So let's walk through this and then download this or clone this repo in my local environment and on my laptop, and then run the demo. So I think I've already mentioned about the prerequisites. So I have Docker running. I have the Lakefest playground or Lakefest running. So let's start this setup process here. All the instructions are available in this repo. So let's clone my repository, this Lakefest samples repository. So let's go to my terminal here and just run this git clone. It will take a few seconds to download this samples repo. So while this thing is going on, let me copy the next command here. So once you clone everything, then you'll run this this container, basically this demo in a Docker container. So let's copy this command also to run the container.
So basically this mimics like an environment, right? So this has like Spark and Delta if you need, and other things just for us to be able to, this is whatever does not run on Lakefest Cloud today, just for the sake of using it.
Correct. So if I go into my Docker container list, so I can see I have this new container, Lakefest Spark Python demo container, and everything is packaged in one single container. So the only requirement is run this container anywhere you want to run, locally or on a server. And then this container has all the notebooks. It has Spark, also it has Python, plus as you mentioned, Airflow, Delta Lake, and all those things everything is packaged in a single container. So once you have this container running, you go to the Jupyter Lab UI. So Jupyter Notebooks, Jupyter Lab is also packaged in this. So this is running in the local environment. So this is local IP address. But if you're running on a server, you'll point it to that IP, server IP. So let's go there. So this is the Jupyter Lab environment. So here you can see all those different notebooks which were packaged in this container in this as part of this repo. So we have Spark demo and so on, different notebooks here. But today we are going to focus on a Spark demo. So basically we are ready for the demo now. So just kind of repeat the process, the whole process. You basically sign up for the Lakefest playground, or you install Lakefest locally in your environment somewhere, and then you clone this samples repo and then run as a container in your local environment. And now everything is up and running. So we are ready to go. Anything else you want to add, Ido, if I missed?
No, so far I have Lakefest up and running. Now, I have an environment, like I'm assuming that everybody have their own environment. We set up as an example. So now I'm going to start configuring my environment to be able to use Lakefest, right?
Correct. So in this case, I'm using Python and Spark code here. So I'm going to set up some of the initial configuration parameters here or variables here. Like from this, I want to connect to my Lakefest environment, so I have to provide my Lakefest credentials. Again, those credentials are sent through the email if you are using Lakefest Playground. But if you install on your own, you will have those credentials. So I need this URL to connect to the Lakefest server. So let's copy this. So this is my Lakefest endpoint variable. So let's point this to Lakefest Playground in this case. And then I need access key and my secret key also. So just to repeat again here, I'm just setting all these credentials as a variable, which I'll be using in the following steps. And then set my storage information. If you want to create a new repo, you want to define your storage namespace where you want to create this repository. So if you are running Lakefest in your local environment, you can point it to your S3 bucket or Azure Blob Storage or Google Cloud Storage. But in this case, I'm using Playground. So I'm going to take this. So this is the bucket provided by us, which you can use for this demo. So let's copy this storage namespace or the bucket namespace here and use that. So I'm going to create a new repo. So I'm going to add a new subfolder in there. So let's call it my Amit repo. Again, this can be, if you are learning anything locally in your environment, it can point to any kind of object store. So next one is providing the versioning information or the branching information that we'll be using in this demo. So I have going to have a main branch as my production branch. And then for isolated testing of my ETL code, I'm going to create an experiment one branch. You can create as many branches as you want. And just for this demo, we are going to create just one experiment one branch. And then these are the files I'm going to use for the demo purpose. So these files are also, the CSV file is also included here in this repo. So you don't have to change anything here. So I'm going to use this file. So let me just run these commands here. So this is all I'm setting up as a variable, which will be used further down the line.
So right now we're getting to the point that we're going to set up our environment to work with Lakefest. By the way, if there's any questions for those of you who joined late, just there is astonishingly low number of questions for the number of people that we have here. So if there's any question, maybe Amit, you're doing a fantastic job. Not maybe, for sure. But if there's additional questions, feel free to post them on the Q&A, guys.
So as I mentioned earlier, for this demo, I'm going to use the Python client, Lakefest Python client API. So you can import that Python client and then create a client by passing those access key and secret key and endpoint, which we set up earlier here as a variable. So that's what I'm going to do that. So this will allow me to access, connect to Lakefest server using the API and perform all the Git kind of operations using the API. Then you define the repo name. So this is my repo is already there, but I'm going to create a new repo and use the new repo for this demo purpose. So let's call this my personal repo. So define as a variable, and now let's create this repository. You can create if you want, you can create the repository from the UI itself. You can create a blank repository, or you can create through API. So I'm going to create this repository through the API. So everything is successful. So if I go back here in the UI and then refresh this, so I should have a new repo now. Okay, so it looks good. So if you create a new repo, by default, it has a branch name called main, but you can change it to anything you want. You can change it to call it production branch or anything else. So here you can specify the default branch name, which in my case, I used main. So now I'm going to import this data. So this is let's assume this is my main production branch. And in that, I'm going to upload some data files. So let's go back here in UI. I want to walk through here. There are two steps or two kinds of process to bring the data into Lakefest. One is uploading the object, where you can choose any file from your local environment and then upload into Lakefest repository. That's one option. And then another option is to import the files from your existing bucket. So let's say if you already have your data lake or you already have your data sitting in your existing bucket somewhere, object store, you can point it to it. Let's say, for example, this, and then import that data. So when we import the data, we are not copying the data. We are just getting the metadata about this, all these data files in this bucket. So this is like a millisecond operation. Like in this case, let's say if I want to import this, okay, I'm sorry, there's some issue here. Yeah, I'm running in the playground, so I don't have access to that bucket. Sorry about that. But just to reiterate the process here, when you do import, it will just bring the metadata about these files. It's not going to copy all the data sets. So let's say if you have terabytes or petabytes of data, it's not going to import the actual data. It's going to import only the metadata or the file location information, metadata information about those files. So we can manage those. Okay, so going back to my demo notebook here. So I'm going to import the file through this from Python. So here I'm just reading that file, which is already mentioned earlier. This is the CSV file, which I'm using for this demo. And then I am using this, in this case, upload object API call to upload this file. And then once I upload this, let me commit my changes into that branch. So now I have my data files available in my main branch. So if I refresh here, so I have this CSV file uploaded into my main branch, which is my production branch. For this demo, I'm using just single file, but in real life example, you can upload as many files as you want, or you can import from your existing object store.
So I think what's great is that so far we spun up Lakefest within minutes. And by the way, even if you guys want to spin up Lakefest not through the playground, but actually run it locally or use the cloud, each one of those things takes minutes also, and you can see the website how to do it. And then we configured Python really quickly, and that allowed us, again, seconds, and that allows us to upload, to commit, to branch, things like that. What we haven't shown yet, and I think that's where you're getting right now, is okay, now how do I integrate my ecosystem, my Spark, my anything that I use with Lakefest to read and write data through those specific branches. So how do we configure that?
Yeah, so next thing is, like, I want to use Spark, as you said, for my ETL job and talk to Lakefest server. And for that, there are two options. One is using the S3 kind of API to talk to Lakefest, or we also provide a Lakefest client, which you can run in Spark. So there are two options for this demo. We are going to use S3 gateway. So through my Spark program, I'm going to use this gateway, S3 gateway, to talk to Lakefest server. So that's what I'm setting here in my Spark context, and the configuration, access key, secret key, and endpoint, which I entered in the top to connect to Lakefest. So that's the gateway configuration. So I can read that data using S3 gateway here. So now I am pointing to my repository, which is initially I set that as a variable as Amit repo, and my source branch, which is set as a variable as a main, and the file name, which is the CSV file we just uploaded. So now using this S3 gateway, I'm going to read that file from Lakefest repository and bring into as a data frame. So I can run my ETL job or whatever I want to do the processing using Spark. So just to show this functionality, like how to read the data from Lakefest, you can use this S3 gateway.
So everything is set up. I can write, I can read, I can use Spark, I can do everything. Okay, so now I have my data set, I have my main branch, and I want to develop ETLs in isolation. What do I do?
Yes, so now I'm going to kind of do my experimentation. Let's say I have my production branch, I have all the data, everything. Now I want to create a separate branch and run my ETL code in isolation without impacting my production or main branch or data in the main branch. So let's start that experimentation. So let's just quickly list all the branches that we have. Currently, we have just one main branch, but let's create a new branch using the API. You can do this with the UI also. So I'm going to create my new branch, which is experiment one branch, which I set as a variable in the beginning. And my source branch is my main branch. So I'm creating this branch from my main branch. So if I go back to my UI just to verify, so now I have my two branches. This is my main production branch. I have experiment one branch, which is separate, and I can use this in an isolated kind of environment to run my code. And if you see that when I create this branch, it took like a millisecond operation, and it will take the same amount of time if you have terabytes of data, petabytes of data, because what we do is zero copy operation, as Ido mentioned earlier. So if you see my current, both the branches have the same commit ID. What this means is both branches are pointing to the same data set, same data files. And we are not copying the data, it's just the pointers to those files. So let me explain that with the picture here. So let's say this is my first commit, and in Lakefest on my main branch, and that commit has 5 files in this bucket. What we store is just the pointers to those files. So internally with each commit, for example, in this commit, I have these 5 pointers. And when you do another commit, in that, let's say something changed, one file changed, or a new file came in and this file got deleted. So now we have the new pointers. So in Lakefest, we just have the pointers to those objects stored in your bucket. So when you create a new branch, we just copying the pointers, not the actual data. So it's a zero copy operations to create a new branch. Only if you, in your new branch, if in your ETL job or something, if you change the something data, then only it does copy on write. And then again, we'll just store the pointers to those new files. So that's how it works internally. That's how we are able to kind of create a isolated testing environment with all the data files. So you can test your ETL code or Spark code in isolation without impacting your production data. Okay, so I got my experiment branch now. So what I'm going to do is I'm going to do some ETL task here. In this case, I'm going to partition the data, and I'll do all this partitioning and everything and write to my new branch. So I'm not going to write to my source main branch, but I'm running this kind of ETL task here in this case in my new isolated experiment one branch. So let's run this task. And here you can do as many a task or as many ETL tasks you want to do. Just for the sake of this demo, I'm just doing one task here and partitioning my data in my new branch. So, and then I can see the difference between those two branches. So I'm running a def branch API call. You can do the same thing with the UI. I will show that. So where I'm comparing my main branch and the new branches and see what the differences between those two branches are. So in this case, I have partitioned my data on this particular column. So you can see what changes happen between those two branches. Again, just to iterate, I'm doing all this work, ETL job in my new branch, in my experiment one branch. I'm not doing it, touching my production branch. So that's where you can see all the difference. And once you are satisfied with this, then you can commit. Again, when I'm committing these changes into my experiment one branch. I'm not committing this to my main branch. So once I commit this change, if you can run again, see the difference, run the difference from the through API, or you can look into also compare here from the UI. So in this case, let's say I want to compare my main branch to my experiment branch, and you can see all the changes that happen in my experiment one branch. So, and if I look into all the objects also, I can see here, like in my main branch, I just have CSV file. I don't have partition data. But if I go into this experiment one branch, I have my partition data also. So you can run all this ETL task in isolation from your production environment in this separate branch. Then you can compare those things. And if you are satisfied everything, let's say if you are not experimenting, this was your staging environment, and you are running your ETL job in this staging environment, you can, once the ETL job finishes, you can merge that into your production. But if you are just doing the experiment, you can delete this branch also. So you can come here once your experiment is done, you can delete the branch without ever impacting anything in your production branch. So now if you see this commit ID has changed because I have changed data set in this experiment one branch. So let's look into like how you will do the merge operation. You can do the merge operation from the UI, or you can do through the API call also. So now let's say this was my staging environment, and I'm happy with everything, looks fine. I can see all my changes here in my CSV file, what changes happened. And once I'm satisfied, I can merge this into my production branch. So I'm going to merge this experiment into main, and I'm going to select the default strategy. There are a couple of strategies where if you have conflict, which will win, whether source will win or destination will win. So in this case, I'm just going to pick a default strategy and merge my changes from experiment one branch to the main branch. So now if I go into look into my objects, now inside my main branch, now I have this partition data set also. And again, this is all atomic promotion, atomic merge. So let's say in your experiment one branch, you change 100 subtables. In your ETL job, you change multiple tables. When you merge, everything promotes to the production atomically. So everything happens once in millisecond operation. All your changes in your ETL task, all the data file changes, everything gets merged into your production branch at once. And also here, if I go into commits, I can see all the changes that happened in this main branch. So for example, in this case, I added my first file, initially uploaded my data set, I partitioned my data, and then I merged this experiment one branch into the main branch. So you can see all those changes in all the different branches. And then you have all these commits. So let's say in case of main branch, I merged all my changes into my main branch, but if something goes wrong, I can also roll back the changes. So I can, let's say I want to, I made the mistake, I partitioned my data, but I now want to roll back or remove my partition. So I can take this commit ID, and then through API call, I can roll back my changes.
That's incredible. Thank you. We covered a lot more than just developing ETL pipelines in isolation. But I think the clear thing from here is that you can spin up Lakefest quickly. You can then quickly integrate it with your Spark in a few ways. We have one example here. And then you can branch out without copying the data and develop against a completely virtual copy, I guess, of your production data in isolation. Thanks, Amit. That's really, really great. I'll share my screen now. I'll go back to sharing. So we reviewed this. There were questions here before, so I want to make sure that I also answer some of those questions that were here. But before I do that, just to sum up what we just spoke about, using Lakefest, we saved tremendously amount of storage. We increased our data engineering efficiency at a lot. We say double. I think it's a lot more than that, because these operations of getting environments, testing environment, troubleshooting environments, trying to recover, those are all things that take a long time and they can take milliseconds with Lakefest. And of course, there's never ever another outage that has to do with data, because we can always revert back in milliseconds if we needed to. Lakefest is open source. You're welcome to use it. We also offer enterprise support for it. as well as a hosted solution for Lakefest. In both cases, the cost starts at around few $1,000s a month. So it's not a very expensive solution in the world of data engineering. What's next? We'll follow up with an email with some links for you guys for our community Slack. We're fortunate to have an incredible community that's very responsive, and playground in the repo. And for those of you who are asked about the answers of the other people here, so we'll split right in the middle in terms of people that heard of Lakefest and didn't, which basically to me says that not everybody answered because we had an uneven number of people. And we have a similar amount of cloud usage here, just over 40% for AWS, Azure, and cloud, meaning some of us are using more than one cloud. So that's kind of the ecosystem of the people that are on this call. And we also have a big Databricks here. More than half of the people here are in Databricks. Thank you, everyone. I really appreciate your time. There's one last question here. You want to give it a shot and answer that. Other than that, I hope you give this a try, and hope to see you in our community. Thank you so much.
Thank you, everyone.